Hello guys, welcome to my channel C Patel Metallurgy. Today we are going to see a numerical in X-ray diffraction. So if we see a X-ray diffraction, the intensity versus lambda graph which we obtain, and it is somewhat like this. This is nothing but K beta, this is K alpha, this is lambda, this is intensity, right? And this wavelength is called a lambda SWL, shortest wavelength. Okay, the meaning of this is that the minimum wavelength of the X-ray which is produced when electrons hit a metal target, then this is the minimum wavelength which is produced. And if you see in the case of K beta, this is a fixed wavelength. K alpha, this is also a fixed wavelength. Okay, and what happens that if you change the voltage applied across the cations and the anions, like the anode and the cathode, like we have the copper target, suppose, and from here electrons strikes. Okay, so this is electron negative, so this is cathode and this is anode. If we change the voltage, like suppose 20 kV, if we change the voltage like 30 kV, then lambda SWL, this one changes. Okay, but what happens to K beta and K alpha? K beta and K alpha does not change. Only there will be change in the, suppose this is there will be change in intensity, but the wavelength will be same. Why this happens? Sorry, why this happens? Because if you see K alpha and K beta, then what is this is nothing but called as characteristics radiation. So characteristics radiation always generated, like you say K cell, L cell, we have M cell, right? 1 2 3 4 5 6 7. Okay, now suppose when electron hit a metal, then what happens? This electron is ejected. Yeah, this electron is ejected. Now since gap is created, so one electron may fall from this position, from L cell. Okay, and since this electron falls from L cell, then this is called as K alpha. Okay, now if the electrons will fall from M cell to K cell, then this will be called as K beta. Okay, so depending upon from the which orbit the electron is falling, this is called as K alpha and K beta. KLM, so mainly K alpha and K beta is observed. Okay, so now if you see our question, so we have applied voltage of 50,000 volt. Okay, so what is the velocity of the electron which is traveling? So we know that for a charged particle, for electron, okay, for a charged particle, energy is E into V, that is charge into voltage. So that will be equal to, I have calculated this one, so 1.6 into 10 power minus 19 into 50,000, right? So this will be equal to, and this energy, this electrostatic energy will be converted into what? Kinetic energy. Yeah, right. So from here, from this equation, we can write V is equal to 2 into 1.6 into 10 power minus 19 into 50,000. Yes, divided by mass. Mass, what is the mass of electron? 9.1 into 10 power minus 31 kg whole half. And I have calculated this one, and this is nothing but 1.32 into 10 power 4 meter per second. So here we have calculated the velocity of the electron which is striking the metal target. So first one is done. Okay. Now second one is, what is the kinetic energy? So kinetic energy will be what? The product. See, the kinetic energy is nothing but is equal to EV. So that will be equal to 1.6 into 10 power minus 19 into 50,000. So this will be equal to 8 into 10 power minus 23. Okay. Now third thing is, this is second. What is the third thing? Lambda SWL. Okay. So lambda SWL. So lambda SWL, if you see the formula, that is nothing but 12,400. Sorry. Divided by voltage. Sorry, I'm feeling actually cold. Extra. This is the formula. Okay. So if you put here 50,000, then this will come around 0.248 angstrom. Okay, so this is the shortest wavelength of the of this material at this voltage, whatever the target it may be. And the next thing is maximum energy per quanta. You see, maximum energy per quanta. Maximum energy per quanta. Okay, so we know H equal to E is equal to H mu, that is Hc by lambda. This is the quanta energy. So here we will put H, the value of H is what? 6.626 10 power minus 6.626 in 10 power minus 24 3 into 10 power 8 lambda, what we have got? 0.248 angstrom. Okay, so from this you can calculate the energy also. I have now calculated it. You calculate by yourself that what will be the energy. Okay guys, so thank you.